Good day to everyone attending. My name is Alessio Alario. I'm product manager for the AnyGrid family here at Phocos. And that also includes AnyBridge, which is what we'll be talking about today. The AnyBridge AB-PLC and FocusLink cloud service. Today's meeting will be recorded. So if I won't mention any names of anybody who may ask questions. Therefore, you can just go ahead and ask questions during the session in the chat window or in the Q&A window that you should have from Zoom. And we'll jump right in. You will receive the slides after the webinar today. And if you have any questions, just feel free to write them down in the chat or the Q&A. I will try to answer those questions during the sessions where it's applicable and where the questions are relevant to others as well. If I can't or if I don't, then I certainly will at the end of the session. I will take at least 5 minutes. This is a 1-hour session, so the last 5 minutes will be Q&A for anything that I may not have answered during the webinar. All right, so we'll get started. So first, I'd like to clarify something. Namely, we're talking about two products today. As I mentioned, it's the FocusLink Cloud and the AnyBridge AB-PLC. And I'd like to define what those products are and how they are interrelated. First, let's look at the FocusLink Cloud. This is our Phocos cloud service, which presents you a monitoring and control internet portal, so that you have access to your power system from anywhere in the world. You can already sort of see what that looks like. You have several charts to give you a visual indication of what your system is doing. You have a power flow diagram, and a lot of these details I'll touch base upon during the session. So this is the Phocos hosted service. This is hosted in Europe. That's important to note as well. So our servers are in Europe. We operate under the GDPR, the data protection guidelines of the European Union, which effectively means that we do a lot to encrypt your data, to make sure that your data is kept safe and that your data is your data. In other words, if you wish to have your account and its contents deleted at any time, then just drop us a note, contact us, and then we will do that for you and clear out your account. This is an important distinction to some other companies that offer web hosting in countries that are not covered by the GDPR, because they have a tendency to be significantly more lax with data and security. What's also important to note is that all of the communication going to and from the cloud portal is fully encrypted. So we know what the FocusLink cloud service is. Now, what about the AnyBridge AB-PLC? Well, that is the hardware component. It's what you can see on the right. This is the hardware that connects your power device. I will refer to power device because effectively it groups together a number of devices, especially in the future. For now, we have compatibility with the AnyGrid PSWH family of hybrid inverter chargers. In the future, we will also include the PSWB family of inverter chargers and possibly some other products going forward as well. So for now, I will refer to your inverter in this case as being the power device that's connected to the AnyBridge AB-PLC. So you can see in the diagram here, we have one or more PSWH power devices that are connected to the AnyBridge AB-PLC. Just a clarification, AnyBridge is the family of product and AB-PLC is the model name. So this specific product is the AB-PLC, where AB stands for AnyBridge and PLC for FocusLink Cloud, because this is effectively your gateway, your connection to the FocusLink Cloud. So this device allows you to connect to an existing router, to therefore connect to the internet and to connect your device to the FocusLink cloud service. And this in turn will allow bidirectional communication between your power device and the FocusLink cloud. So in other words, uploading data from your system onto the cloud portal and also downloading data in the bidirectional communication that we offer. So as a customer, what are your benefits in all of this? Well, there's 3 main points and a few more that I'd like to outline. First, you get a pretty much real-time view and a historical view of what your power system is doing. So you could already see on a previous screenshot that there's a whole bunch of different graphics and charts that really give you a very good idea of what the system is doing and still keeps it clear and easy to read. So it's important that you can easily navigate this information and potentially use that for the second point, which is to optimize your AC loads. In a lot of grid-connected systems or off-grid systems, it's particularly important to optimize the AC loads. In off-grid systems, more so than grid-connected systems, actually. Let's say, for example, you do have an off-grid system. So it means that you have absolutely no connection to the public grid. Well, in such a case, during the day, if we're assuming this is a solar system, a PV system, where you do have a battery and solar panels and AC loads, in such a system, typically during the day, during the hours with the most sunshine, or certainly during the afternoon, depending on how you've sized your system and how many AC loads you have on that particular day, you will end up with a lot of excess energy. In other words, for your system to be able to provide power to your AC loads continuously, unless you're living right near the equator and you don't have any monsoon season, nothing at all, you have pretty much the same seasonality throughout the whole year, which is obviously very rare. In most cases, you will have to optimize for the worst months in the year. So typically for winter, wherever you may be located in that system. That does mean, though, that during the summer, you will have a lot of excess energy. So essentially, you will have too much energy. Of course, now it's important to manage your AC loads so that you can take advantage of that extra energy you might have during these midday hours or early afternoon, and to avoid running heavy loads, high consumption loads during the night when essentially you're only running off battery, or maybe if you do have a backup generator, running off a genset, which in turn will cost you fuel, etc., have emissions, all these things. So you can use this FocusLink Cloud Portal to optimize when to turn on and off your high power AC loads. In a more residential environment where you might be connected to the grid, this could include your washing machine, cooking, maybe you have an electric vehicle, be it a scooter, a motorcycle, or a car. So all of these loads you will tend to want to run during the day when you are likely to have excess energy left over, and you want to avoid running them in the night or in the morning when essentially your battery are probably nearing depletion. They're being discharged throughout the night. So you want to make sure that you use the batteries only for your bulk loads, your main loads, but not those big, large loads that tend to discharge your battery very quickly. And the third pillar here is minimizing costly site visits. What we mean by that is if you're an installer, for example, and you're installing a PV system for customers and you're taking care of the technical aspect of that, maybe you're even selling power as a service, or at least you have some service level agreement to and essentially ensure that the system is running smoothly. Having a good overview of what the power system is doing can really help you out to not only optimize what the system is doing for the customer, but also in case of any issues, you can do a lot of the diagnosis from afar and see what's happening in the system before even visiting the customer. In many cases, you can tell the customer to do something, or you can change some settings on the inverter remotely, so that you can actually avoid visiting the customer altogether. And that, of course, in turn can save a substantial amount of money if you look at that over a period of years. Some more benefits are that you can monitor and control multiple solar devices. At this point, this means 1 to 3 AnyGrid PSWH inverter chargers. In the future, that will also include more PSWH devices. There will be a tier of this product that will allow you to access up to 9 inverters and to monitor and control each of them individually. But for now, it's 1 to 3 units. Also, you can analyze and export your data. So not only can you see all of the data nicely presented in the cloud, but you can also download that data and use it to do your own analysis, or maybe use it as a backup, or export that data into some spreadsheet program of your choice. I'll show you what that looks like later on. And then point number 3, you can use this device with any internet browser. So be it a computer, a laptop, a tablet, a mobile phone. You'll see later that not only does the view adapt to your screen, but there's some other technologies and features that we're using to further optimize the experience for different screens. Then, of course, this is available from anywhere. Not only is it possible to access this from any device, so it doesn't matter what operating system you're running on, Linux, Windows, iOS, Mac OS, or Chrome OS, or whatever. Anytime you have a reasonably modern internet browser, you can access the cloud from that device. All you essentially need is an internet connection, of course. Then you'll see we have quite an intuitive and modern dashboard, which really allows you to navigate things very nicely and easily. There's essentially no learning curve. It's pretty much self-explanatory, the portal. And then finally, you have your whole system status at a glance. So you can drill down to individual aspects of your device. But first and foremost, you can see what's happening right now. What are my power flows? And that tends to be the view that people will probably use most frequently to essentially at a glance see what their power system is doing. So now let's look a little bit more closely at the Bridge AB-PLC hardware. So this is essentially what you purchase. When you purchase the AB-PLC, you get 24 months of free access to the FocusLink cloud service. And you get the AB-PLC, of course, which is the device pictured here. As I've already mentioned, it's compatible with AnyGrid PSWH family hybrid inverter chargers. At this time, 1 to 3 devices. So if you have 1, 2, or 3 devices, the AB-PLC can talk to them. The devices are treated as a single virtual device on the cloud as of now. So essentially all of the power flows are summarized. So all of the PV generation is summarized between multiple units, the AC output, AC input, battery flows. And for the voltages, we take averages across the units. PSWB inverter chargers, which is another member of the AnyGrid family of inverter chargers, will also be supported soon. So we're currently working on implementing support for those. Then the second last point, you do not require an external power supply. You'll see that the cable is actually included here to really plug and play, connect to your PSWH inverter. There's no need for any external wall warts or power supplies of any kind, because the connection that you make to the inverter charger both provides the data interface to query the device and to speak to the inverter, and also powers the AB-PLC from the inverter. And as the last point, we've opted to choose an external antenna. Of course, that antenna is included with every AB-PLC. The reason we did this is twofold. First of all, the range tends to be much better with these types of antennas, especially because we have a nice metal housing for this product. The range tends to be much better with an external antenna. And the second reason is it gives you a lot more flexibility. If you find that maybe your inverter and your PV array is not as close to your internet access point as you might like, a typical example I like to take is, for example, for a farming site, where people might have a living quarters, so a house where they live in, and then separate from that, a lot of farmers have a barn with animals, etc. and for storage, for food, for the animals. And that building tends to be much larger, of course. The barn tends to be significantly larger than the living home. So it tends to be logical to put the solar array, the PV panels, on the barn as opposed to the living home. And in such a case, you would have the inverters, you tend to want to have the inverters pretty close to your solar array for your power generation. Then you will run AC wiring down to your home where you're living. Obviously, in most cases, the internet is going to be at the home where you're living, right? So in such a case, you could set up the AB-PLC to be nice and close to your inverters, and then take advantage of this better range that the external antenna gives us. And furthermore, if that's not sufficient, you can go ahead and exchange that external antenna for a different model. You can get higher gain antennas, or even more specifically, you can get directional antennas. These types of stick antennas, they are called omnidirectional. So they will radiate in all directions, which essentially means that you have access from all direction. That's the upside. The downside is you have lower range than a directional antenna. Directional antennas are very rare. Most routers and things like that have these omnidirectional ones. But the unidirectional antennas, they tend to look a little bit like, look a little bit like a satellite dish or a rectangle. And you need to make sure that they're pointing in the right direction. So in this case, you want to point them towards your internet router. But you could massively increase range that way. You can get hundreds of meters sometimes of range without increasing the power draw whatsoever. So this really gives you a whole bunch of extra flexibility if you have a significant distance between your internet access point and the Bridge AB-PLC. So continuing for the wireless connectivity, as I've mentioned, we have Wi-Fi. We support the B, G, and N standards at 2.4 gigahertz. So if you're using the Wi-Fi functionality, do make sure that you have a 2.4 gigahertz network to connect to. The range with the included antenna is approximately 46 meters, which is about 150 feet. Indoors, we already include walls and things like that, but of course this can vary. If you have concrete walls with maybe some steel shielding inside, of course, then that will be drastically decreased. The other extreme, if you have a line of sight, then you will probably have more range than this. And again, if you're running out of range, then of course you can use a different antenna as well. You have that flexibility. The antenna is connected with a standard SMA connector to the housing of the AB-PLC. This is the same type of connector you'll find in any standard router. We've done this on purpose so that it's very easy for you to source an alternative antenna if you were to need one. Do be sure, though, to comply with your local radio emissions requirements if you do exchange the antenna. Now, Wi-Fi isn't the only wireless form of communication for this device. We also support BLE in version 4.2. So any mobile device you might have, for example, that supports BLE, anything above version 4.2 will do. And we use that to do the initial setup of the device. The range for that is 10 meters line of sight, as is typical for BLE. Now, looking further at some of the wired interfaces as well. Starting from the top of the list, we have the MXI interface, which is the number 1 here. This isn't currently used at the time, but these connectors 1 and 2 are more for future proofing to make sure that in the future we have the ability to talk to new and upcoming devices, and that we can therefore offer a broad range of compatibility in terms of which power devices can interface with the AB-PLC. The RS485 connector equally is for future implementation. You'll see that actually 2 contacts of this connector I will touch base upon later in this session. Then we have connector number 3, the RS232 interface, and this is the most important one for you. That's where you connect to your AnyGrid PSWH hybrid inverter charger. So again, this will ensure that not only is the data communication present between the AB-PLC and the power device, but also the whole device, the AB-PLC is being powered through that same connector. Number 4 is an LED. It's a power indicator that's showing you that the device is being powered. And number 5 is equally an LED to show you the portal connectivity, to show you if you're connected to Wi-Fi or the FocusLink cloud successfully. Then number 6 here, we have a reset button. Should you want to reset the device, in other words, delete all of the information that you've entered in it. There's not that much you can enter into the AB-PLC at this point. It mostly consists of the account that you're tying to on the FocusLink cloud. You'll see later that's your email address, and all of the Wi-Fi credentials you may have entered to connect to your local Wi-Fi connection. So if you want to reset all that, delete that for troubleshooting purposes, or because maybe you want to sell the device on or give it to somebody else, then you can go ahead and do that. If you're an installer, you can go ahead and test it and then just delete everything and pass it on to customers. Number 7 is the LAN port, the Ethernet port. So it's up to you if you want to use Wi-Fi to connect to your router to connect to the internet, or if you want to use a cable-bound standard Ethernet port, you can go either way here. And then finally, number 8, as you've already seen, that's the antenna for Wi-Fi and BLE. Now I'd like to go through the setup process. You'll see it's quite simple and not very involved. The first step is to ensure that your AnyGrid PSWH units have firmware version 6.18 or higher for the U2 firmware. There's 3 firmwares on these devices, and the U2 firmware is the one that's responsible for the display unit and for all of the communication functions. And this is where we require 6.18 as a minimum version to make sure that the compatibility is there between the AB-PLC and the inverter. If your inverter does not have 6.18, then you can go ahead and contact us for now, but in just a few days, we'll have the firmware up on our website. You can find that firmware by visiting the Bridge ABPLC product page, and then you can directly download the most current firmware for your AnyGrid PSWH inverter. Of course, you can go ahead and do this without the AB-PLC. So you can prepare this even before you get your hands on an Bridge AB-PLC. The requirement for doing the firmware update is essentially just a RS-232 port. Of course, many computers nowadays don't have a native RS-232 port, so there's RS-232 to USB converters, which will cost you typically between $5 and $10 US. They're available pretty much anywhere on online platforms and pretty much any computer store. And the cable that's required to do the firmware update is already included with every PSWH. You'll find then, once you do get the update files, regardless of whether you get them from our website or from our support team, there's detailed instructions with screenshots on how to do that. So once you've updated or ensured that your inverter is corresponding to the 6.18 firmware version, you can go ahead with the setup of the AB-PLC. And for that, you simply connect the cable that's included with your Bridge AB-PLC between the RS-232 port of the AB-PLC and the RS-232 port on the AnyGrid PSWH inverter charger. Again, that cable will ensure that the AB-PLC is both powered and is able to communicate with the inverter. Then if you are using Ethernet to connect to your router and thus the internet, you also, of course, on the other side, need to connect the Ethernet port to your local area network. If you're using Wi-Fi, then that's it. That's all the wiring there is, just that single cable between your inverter and the AB-PLC. The next step is to download the FocusLink Mobile App to an Android or iOS device. You can find the QR codes here for the download. As I've mentioned before, we will share these slides with you, so you can find that easily. Also, of course, the manual of the Bridge AB-PLC is online as well on our website. So you go ahead and download the FocusLink Mobile App for either platform, Android or iOS, and then open that app, and this is where we almost finalize the process. When you first open the app, you scan for BLE devices. You'll find the any Bridge ABPLC. If in this case you're using a PSWH inverter, you will also see the inverter because the inverter also has BLE connectivity. In this case, you select the any bridge, and then you will be greeted with this screen. The fact that the relay is green and closed here already indicates that you've successfully connected to the Bridge ABPLC because it's the default setting for the relay. I'll mention what that relay does a little bit later in the session. So to do the setup, you just tap Setup, and here you will be greeted with either 2 or 4 fields, depending on whether you're using Ethernet or Wi-Fi to connect to the internet. If you're using Ethernet, then essentially you just have these bottom 2 fields. The first one is the name of your system. It's the name of your power system, the way it will appear on the FocusLink Cloud portal. For example, you can, on a single account, you can have multiple power systems, and this is how you can distinguish them from one another. The second field is for your email address, which will serve as your login credential to log into the FocusLink Cloud. If you're using Wi-Fi, in other words, if nothing is connected to the Ethernet port of the ABPLC, then these 2 fields above will also be visible. The first one is to enter your access point name, your SSID, and the second is to enter the password for your Wi-Fi access point. Do make sure, again, that you're using a 2.4 gigahertz access point and that you're using WPA-PSK as the security for that, or WPA-PSK2. Once you tap Submit, you just have to wait a little bit. The app will go through these 4 steps, and every time it's finished with a step, it will give you a green check mark. If you are using Wi-Fi, then it will use that to connect to your Wi-Fi network, then in turn to connect to the FocusLink Cloud, regardless of which method you're using to connect to the internet. And then the last step is an activation email, which will be sent to the email address that you've provided here. And that's almost it. Here's the last step, which is essentially just clicking on the invitation link that you've been sent by email. And then you can define your password and log into the FocusLink Cloud. Immediately after the setup, the FocusLink Cloud will start transmitting, the ABPLC will start transmitting data to the FocusLink Cloud. And from then on, essentially, you don't need to mind the system anymore. It will take care of itself. Like I said, it's powered by itself. You'll see later it updates itself. So really, this is a very simple setup, and then really a set and forget system. So next, let's look at some of the FocusLink Cloud features. The first one is the power flow diagram. Now, if you've already used the AnyGrid PSWH series of inverters and have used our app to connect to them via BLE, you will have seen a very similar power flow diagram in our app before. This essentially gives you a very quick view of what your system is doing and of the various power flows. We're purposely not differentiating between DC or AC. We're not giving any voltages here because this is about power. Where is your power coming from, and where is your power flowing to? So you can see on the top, you have your PV array producing a certain amount of power. That power is being fed to your AC loads. Some of it is going to the battery or being taken out of the battery, depending on how much PV is available. And then you're either sourcing energy or power from the grid or backfeeding it into the grid if you've activated feed-in in your inverter. So I think this will be the most popular way of just very quickly getting a good glance of your system and what it's currently doing. The next feature is seamless zooming. Now, there's a few things to this. First of all, you can see here in the animation, if you just highlight a portion of what you're currently viewing, up here we have the power mix. So essentially, it's a time series of what you've seen previously in the power flow diagram, which is the PV power, the AC input, AC output, and battery powers. So you can select any portion of that chart and therefore zoom in very intuitively. If you look carefully, there's a few other things that you can already see in this animation as well. If you point your cursor over that section in the chart, you can see the cursor is synchronized across all viewports here. So this is very, very practical because it means that up here, we're looking at power. In the middle here, we're looking at state of charge. Down here, we're looking at the operation mode of the inverter. But all of these views are synchronized. You know exactly where you are in all of the views by just putting your mouse over a certain data point, and then you can automatically see that it's synchronized across all the different viewports. Furthermore, you can see that beside your cursor, your mouse, or if you're tapping it by hand, then the last position, you can see the powers or all of the data points that are associated with that point in time. And again, this is synchronized across all three views. So like that, you know exactly what, for example, at 1 p.m. on a certain day happened across all of the different views without, having to flip back and forth between charts or looking for times, etc. A next feature is the historical analysis. You can go back in time as far as you need to, over months and even years. And to be able to do that, you can select the time interval that's being shown here, up here in a calendar view. So you can select a starting and an end date, and then all that data is aggregated for you, summarized in your viewport. You also have some practical presets you can see on the right here for the last few minutes, hours, or days. So this gives you a very quick way to select like what happened last week, for example. Maybe you weren't home, maybe you were on vacation, and you can very quickly see a 7-day interval or a 2-day interval of what happened in your system. The default view is 24 hours because that tends to be the most relevant one if you regularly look at your system. So I think here too, you can immediately see in the animation, as soon as you connect, you select a time, all of the charts automatically adapt to that. So again, all of the different charts are always synchronized to what you're doing. Next, we have cumulative energies. So where the other charts that you've seen so far with power, for example, or state of charge, are essentially collecting data in a single point in time. For your information, we upload data every 5 minutes to the cloud. And what happens within those 5 minutes is averaged out and is summarized on the AB-PLC so that you don't lose any data. And what the cumulative energy does, it will show you the cumulative watt hours or kilowatt hours for 1 hour in time. So you can see the bar charts here. Each bar represents 1 hour and how many kilowatt hours were produced or consumed during that time. Now you get these charts for everything, for your battery, for your AC output, your AC input, and your PV array as well. Next, we have the data export. I've already mentioned this. You have the possibility not only to see everything online, but also to download the data for your own purposes, be it to analyze it with Excel or LibreOffice or any spreadsheet package of your choice or any other program that can read CSV files. CSV files are very easy to use, just comma-separated value files. I think pretty much every spreadsheet program on the planet can support CSV files. So that's just a very easy way to download the data and then to use it elsewhere if you need to. You can also effectively use this as an offline backup for your data. So that even if you close down a system, or even theoretically if you sell on the AB-PLC or something like that, you can still keep your data even if you don't have any access to the portal. Or you can download the data and maybe analyze it on the go even if you have no internet connection. I've already mentioned that the FocusLink Cloud is optimized to be used on multiple different screen sizes. So I think the most obvious part of that is the so-called responsive design. And what that simply means is that the FocusLink Cloud dashboard will see what your screen size is and will adapt itself accordingly. So you can see here in the background, you can see a tablet screen, and you can see the various rectangles here. The viewports are spread across so that you can maximize the screen real estate and just have the best possible view on your screen. And if you're using a vertical phone, for example, then all of these things are rearranged in a vertical fashion so that things still remain legible. Not only that, but also the density of the chart is actually adapted to your screen size. So in other words, if you're looking at a long period of time, let's say you're looking at 7 days of data. So yeah, I don't want to do the calculation now, but every 5 minutes you'll have a data point, and multiply that across 24 hours times 7 days. That's a lot of data points. Now, if you have a big screen, that's great because it gives you a lot of resolution and detail on your data. But if you have a small phone, then it's no use to download all of these data points and then to display them in essentially a very small screen. So automatically the FocusLink Cloud will downsample that and make sure that it fits nicely into your screen size. Also, obviously, because all of this is essentially a web app and therefore web-based, we are completely multi-platform, as I've mentioned before. It doesn't matter what operating system you're running on. And then the final key feature I'd like to present today is that from the beginning of development for this product, we've optimized everything for low data rate. What that essentially means is that the communication between your power unit, your power device, and the FocusLink Cloud is made with minimal data overhead. The reason we do that is probably easy to understand. A lot of our customers will be in remote locations, will be in countries or areas where there is maybe no wired internet, so they will be using wireless internet of some kind. And a lot of these wireless providers will put a data cap or will essentially ask you obviously to pay more money for more data some way or other. So it's very beneficial to have the lowest possible data rate for the data that's being pulled out of your inverter. So this ensures that if you do have data caps, that you don't reach them too soon, or if you have a variable internet of some kind, or you're paying per gigabyte or per megabyte, that you pay as little as possible for your internet data feeds. Also, a point I'd like to make here, some people may ask why, do we have a 3G or 4G solution or something like that? We've purposely tried to stick to the most common technologies, which is Wi-Fi and Ethernet for the local area network. Because if we were to offer, let's say, a 3G or 4G variant for a direct, you put a SIM card inside, that brings a host of issues because from country to country, the cell phone frequencies are different, the operators are different, the plans are entirely different. Some people may be using satellite internet or DSL or fiber. There's just so many different ways of connecting to the internet that it's not really possible to make a product that can cater towards all of these and still make that reasonably price effective. So instead, we've opted to give the customers a choice to go ahead and buy just a standard generic router in their country or location that will connect to the internet that they're using. So this could be a router designed for a wireless connection, a cell phone connection. It could be one designed for satellite, DSL, fiber, or whatever. Essentially, all of these routers allow us to connect to them via Wi-Fi or Ethernet, which is what we're doing here. The AB-PLC will then connect to that router through Ethernet or Wi-Fi, and therefore essentially be treated much like a mobile phone or laptop or a computer would in your standard router. So that's why we made that decision. Next, I'd like to show you some of the upcoming features. Now, what's common with all of these features that I'll be showing you in this section is that they will be delivered to your AB-PLC automatically. The AB-PLC can update itself. It regularly checks for updated files. If it finds some which are newer than the files it has, it will download that new firmware, and then it will transparently update itself. That really requires absolutely no user intervention. So if you're using this in a very remote location, you don't have to worry about it. As soon as the internet connection is there, it will check if there's a newer version, and if so, it will update itself. The second point is that all of these updates I will outline here come at no extra cost. So there's no additional costs for these updates that I'm outlining here. And then finally, as I've already said, this is really a set and forget affair. You don't need to worry about updates here. because the AB-PLC will just update itself. We do have a question here that an attendee here is asking about availability in India. We do have a partner in India, and as I mentioned, you probably weren't there yet at the start of the session. We're actually producing a lot of pieces this week, so they will be ready for shipping out this week or next week, and we expect them to be at dealerships within 4 to 8 weeks, depending on how they're being shipped to our customers. So the upcoming features, I have 4 here I'd like to outline. The first one I've already kind of mentioned, that is the support for the AnyGrid PSWB series. As I said initially, the AB-PLC will support 1 to 3 PSWH units, but we are working on implementing PSWB support as well. The second point is the ability to configure essentially all of the AnyGrid parameters from the cloud. So you can see on the right-hand side here what that will look like. You get your familiar menu points, the same menu points that you will find when you're physically in front of the unit on the LCD display. And you will get the associated values the way they are currently set on the inverter, and allow you to change these values and then to update that new configuration to your inverter. So this is goes hand in hand with what I mentioned, the 3 pillars of benefits that you have. The third one was avoiding costly site visits. Well, if your installer has access to this and can change the settings on your inverter, then that can really help in diagnosing the problem, or maybe optimizing the way you're discharging your battery to make sure that you're not discharging it too frequently, and to just be able to change settings very easily without actually going on site. The third point is a very important one as well. We understand that obviously a lot of these systems will be in reasonably remote locations, and there's no guarantee that the internet connection will be stable. In fact, we did a survey during a field test, and a lot of our customers said that they have very intermittent internet. They might have daily outages or even more frequently. The AB-PLC is designed in such a way that we have a significant amount of storage on board. What that means is if the internet connection drops and if the internet is not available, then the AB-PLC will keep querying the connected power devices, will build its averages, and instead of sending that data to the cloud, it will save the data locally on the internal memory. And then as soon as the internet connection comes back, it will then progressively update the cloud portal with the data that it has previously stored locally. And this way you will end up with a seamless amount of data, and you won't have any holes in your data, even if you have intermittent internet outages. The final point here is the real-time mode. This was also some feedback from our field test. Currently, the update interval, as I've mentioned, is 5 minutes. So during those 5 minutes, the inverters are queried roughly every 10 to 20 seconds. And then we build averages across those 5 minutes and then send that 5-minute interval to the cloud. This, in some cases, if you're playing around with the settings, or maybe if you're doing the initial installation of the system at the customer, can be a little bit too long. You might change a setting. You don't want to wait for 5 minutes to see the effect. So for this, we're implementing a real-time mode where essentially you can go into the FocusLink Cloud portal, just click a button to enable the real-time mode, and then the AB-PLC will actually update the cloud roughly every 10 to 20 seconds, as opposed to every 5 minutes. And this, of course, drastically increases the speed at which you can see any changes that you might have made to the system, or you can see the behavior of loads and things like that. So these are the 4 features that we firmly have on our roadmap within the next few months, which will automatically be distributed to all the AB-PLCs bought from day one. And the 5th one is a very interesting one I'd like to dig a little bit deeper on before finishing off with Q&A, if you have any questions. This 5th feature is support for a solid-state relay. Essentially, I'm sure that most of you know what a relay is. It's essentially a coil, a switch, an automatic switch. A solid state relay is the same thing, except for it's solid state. So it doesn't have any electromechanical components. It is a purely electrical device with no mechanics in it. In other words, it is a semiconductor. Now, these come in two flavors. There's solid state relays, which are abbreviated here as SSR, in AC or DC variants. So in other words, depending on what you're controlling, what you are switching, if you're switching a DC load, for example, then you will need to use a DC solid state relay. And if you're switching an AC load, you will need to buy an AC variant of the solid state relay. So some common manufacturers are Crydom or Photech, and there's many others. They all work roughly the same way. The major distinction, as I've said, is really to look out for whether you need an AC or a DC variant. You can't typically use the AC variants to switch DC loads and vice versa. So these solid state relays can be controlled with pin 7 and 8 of the RS485 connector on the AB-PLC. And this will connect to the control side of the solid state relay. So this is essentially where we signal the relay to either turn on and therefore to close these contacts, or to turn off and open these contacts. Now, why are we going through this effort? This is obviously going above and beyond what most companies do with IoT, with remote monitoring portals and things like that. We really want to give customers that additional feature, that additional amount of control in their system. So that really brings a lot of flexibility, as you'll see in a moment. There's 5 major areas that you can address with using these solid state relays. Now, the control of the solid state relay will initially be done purely on battery voltage. So the battery voltage of your power system will dictate when the solid state relay will turn on or off. And of course, you can decide when that is, at what voltage. So the 5 use cases that I could come up with, I'm sure there's many more that customers will find over time, but these are, I think, the most obvious ones. The first one is load prioritization. You might have some very important loads, things like maybe emergency lighting, maybe a small server, just things that should run as long as possible, that are the most critical parts of your power system. Those are the high priority loads. And then you might have low priority loads, which might be, I don't know, your TV, maybe your computer, all of the non-essentials, maybe your vacuum, just the electrical outlets in your home, etc. So if you want to differentiate between those, so that if you're in a low power situation, maybe there's not a lot of PV power coming in, maybe the grid has failed, you don't have a genset, or you don't want to use it because it costs a lot for fuel, then you want to make sure that you're turning off your low priority loads well before the whole system essentially needs to turn off because the battery is depleted. So load prioritization will help you do that. Then you can use the solid state relay as a control for generators, for gensets. Now, the PSWH, for those that have already used it, it already comes with a relay to act as a generator start and stop switch. This will give you another level of control, because essentially for the PSWH, the generator start is implicit. I don't have time to go into why, but you can see in the manual of the PSWH that essentially depends on the working state of your system, and it's not purely related to the battery voltage. So here you just have a different and arguably more specific and fine-grained control of your generator start. But also later, if once we've implemented the PSWB functionality, the PSWB inverters do not have a generator start switch. So in this case, you can essentially upgrade the functionality of the PSWB with that functionality. Then the point in the middle, we have the excess energy management. As I've mentioned at the very beginning of the session, especially if you're in an off-grid situation where there's no way to sell power, right? If you're off-grid, then by definition, you're not connected to a public grid. So there's no way to sell any excess energy that you might be producing from your PV array to anybody else, to the public grid, because you're just not connected. So the next best thing is to do excess energy management. In other words, you might have a pool or something that you want to heat up, or just the warm water in your home. You can put a heater inside your warm water reservoir, and that heater will be turned on automatically when you have excess energy. So instead of wasting that power that your PV array is producing, that you can still use that to heat something up, or just to run very non-essential loads which would otherwise remain off. The second last point is a low battery alarm. If you're really living off-grid, maybe you're in a cottage or something like that, it can be very important to know when your battery is starting to run low. And of course, you can use this as a switch, because as I mentioned, you can define at what battery voltages will trigger, and just give you maybe an acoustic or maybe just a lamp or something to make it clear to you, oh, my battery's running low, I better reduce my consumption to make sure that I maybe get through the night and the system doesn't turn off halfway through the night. And the last point is a low voltage disconnect for DC loads. You might want to mix AC and DC loads in your power system. And this is a good way to manage those DC loads. I actually have an example, so I'll mention that in a couple slides. So I have 3 examples of how that solid state relay can be wired and what it can do for you. So in this first example, we have an AC solid state relay. So in other words, we are controlling an AC load. Remember that it's important to differentiate between DC and AC solid state relays. So in this case, we want to use it for load prioritization. So in other words, our high priority AC loads are being directly fed by the AC output of our AnyGrid PSWH hybrid inverter charger. So they're essentially powered as long as possible and under as many conditions as possible. That's our high priority loads. And then I might have some low priority AC loads, which I only want to power if I have enough energy in my system. So if my battery is sufficiently charged, for example, because if my grid fails, then my battery voltage will drop unless I have a lot of sunshine. So if, for example, during the night, the public grid fails, then I'm running purely off of battery power. So of course the battery voltage will drop. And at some point in this configuration, I can then turn off my low priority AC loads. So this might be like an air conditioning. This might be the TV, just all those non-essentials. And a high priority load might be my emergency lighting. It might be my refrigerator, for example, to make sure my food doesn't go bad. All of the things that have a higher priority. And this way you can use the AB-PLC to trigger the solid state relay to switch off the low priority loads as your battery depletes. Now going to the second of 3 examples, I'm just going to switch back and forth. You can see it's exactly the same. The wiring is identical, but the use case is actually a very different one. In this case, we're doing it for excess energy management. As I mentioned before, we were essentially trying to protect the battery from dropping too low in voltage by turning off non-essential loads. Now we're kind of doing the opposite. We are turning on AC loads only when the battery is completely full, because that's the way we can get rid of that excess power that we're producing during the middle of the day, when essentially we have a lot more power coming in through the PV array than we can consume with our normal AC loads. So this is, in the example I gave before, this is where I can power, for example, my pool heater or my heater for warm water, any of these, let's just call them luxury items, where I can sink some more energy without essentially having to forego that excess energy. So the wiring is exactly the same, and this time all of my normal loads are sitting on the AC output of the inverter, but these non-essential excess loads are then triggered by the solid state relay. And then as a last example for the solid state relay control, so far we've looked only at AC solid state relays, and now I'd like to give an example for a DC solid state relay and what benefit that can give you. As I mentioned before, you might be using a mix of AC and DC loads. There's a lot of use cases or people that recommend doing that actually. If you're living in an off-grid situation, or if you have very volatile power, or power that's just not available 24 hours a day from the grid, and you're living off-grid for large portions of the day, then some of the items in your home that are consuming power virtually all the time, or at least for a large number of hours during the day, it can make sense to move those over to the DC side. Because obviously PV power is DC, your battery is DC as well, and any conversion to AC and from AC always means there's some loss involved. So if you can, for example, power your lighting from the battery directly from this DC source. So for example, let's say you're using a 24 volt AnyGrid PSWH, then you're connected to a 24 volt battery. You may want to have your lighting in your home powered directly off the battery. And in other words, that's a DC load. Now the drawback and the advantage, of course, is clear that there's very little conversion taking place between the battery and the DC load, so this tends to be the more efficient path. The drawback is that you don't, under normal circumstances, if you connect a DC load directly to the battery, well, depending on how good, let's say, your DC load is, it can essentially draw the voltage of your battery down and kill your battery. It can completely discharge your battery. And if you do that a few times, especially if you're working with a lead acid battery, then essentially that will destroy your battery in a very short amount of time. So that's why most of our charge controllers, our standalone charge controllers, have a load output. And that is mainly used to disconnect your DC loads when your battery is starting to reach a lower voltage. And you can essentially replicate that with a solid state relay, where the DC load is not directly connected to the battery anymore, but rather goes via the solid state relay, which in turn is controlled by the AB-PLC. And this way you can define, for example, that at 21 volts, in my 24 volt example, the DC load is to be turned off automatically. And this way you have a low voltage disconnect implemented in your otherwise AC system. And now, just before I finish up, for if you have any more questions, you can, of course, try this out for yourself, even before purchasing the Bridge AB-PLC. We have 3 links here. The first one is actually a demo of the FocusLink Cloud portal. So you can just use this link to visit the FocusLink Cloud portal, and you get an automatic login with demo credentials, so you can play around with the portal a little bit, see how that works for you on different devices, and therefore get a good idea of at least the main functionality. Some things aren't available on the demo portal. I don't think you can download the data, for example, but you get a good idea of what the graphics, the visuals are like, and how to zoom in and full screen your graphs and things like that. Then the second link is a portal introduction video where essentially I am guiding you through the FocusLink Cloud. You can see that video here. So essentially it's using the demo portal, but myself giving an explanation of the portal. And then finally, the third one is the setup video. You've already seen the setup is very straightforward and simple, but we still give you a video for that. Also, maybe if your customers are installing that, it just makes it even simpler for your customers, because it's literally a walkthrough of every single step that you need to take for that initial setup. So that's everything I have for you today. Thank you very much for joining the session. I'll go ahead and answer some more of your questions that you might have here. And for those that don't have any more questions, I wish you a very good day, and hope that you can join us in a future event. Do check out our YouTube channel, not only for the setup video, but also likely this session today has been recorded and will be uploaded to our YouTube channel, so you can go ahead and look at that later. And otherwise, you will receive an email with the slides of today's session as well. So thank you very much for joining, and have a good day. And for all those remaining, I'll try to answer the remainder of your questions. Thank you very much.
For more videos and information, go to www.phocos.com. Phocos, making reliable energy access possible. Anywhere, anytime, any grid.